Hey guys, welcome to the second part of our dynamic circle tutorial. Again, my name is Devin Sherry, and let's just go over a bit about where we did on the first part. We're working on our dynamic circle here. We were able to make our timeline and also our scaling information, and as well as when the timeline finishes and we reset everything. And we have the ability to set the dynamic circle color, as well as the size of the dynamic circle. For more information, you can check out the first part of this tutorial here. So continuing on from where we left off, up here in the main actual section of our blueprint for the dynamic circle, after when we set the size of the dynamic circle, that's when we want to go ahead and actually play our timeline. So let's go ahead and do a get of our timeline variable, the scale dynamic circle. Let's do play from start. That way, as soon as this is called, the actual timeline will start playing, and then as it goes, it's updating both the scaling of whether or not the circle is smaller or larger than a static circle right here. So with that in place, we have to basically continue where we left off. This is where we're going to actually start doing the logic for when the actual dynamic circle is clicked, as well as the static circle if it's clicked. So let's click on our dynamic circle mesh just so it's highlighted. And if we right click and do on click, we should have a variable here. It says add on clicked, and it'll be an on clicked dynamic circle mesh. So let's compile, save all that, and now we need to make a custom event. Call this click static circle. And basically what we want to have happen is a couple of things. We want basically the timeline to stop, just so the circle doesn't continue to grow or shrink. We also want to make sure the player can't input anymore, and then we want to go ahead and actually get feedback for how close the two circle sizes are, and then start the whole process over from the beginning. So let's create a new macro. We'll call this click on circles. And for the input, we're going to need an executable called in. And we're also going to need a Boolean input called bCanInput. So back into our main event graph, let's go ahead and put that macro in. So let's drag in the click on circles, plug them both into the in here. And then for the CanInput, let's just control left click, drag out the CanInput Boolean. And we're just doing this check just to make sure the player can't click on these circles multiple times and cause any issues. And we forgot to do an output pin, so let's do an executable pin for the outputs, and we'll call that out. Now, we'll grab out the CanInput Boolean input, we'll do a branch, connect it to the in. And if the player can input, that's when we want to go ahead and alt left click, drag out a set, and we're going to set that to false. We're not going to do anything for the false, we're only going to do the true. And now it's from here we're going to grab the scale dynamic circle and call stop. So we're going to make sure that the actual timeline stops. Plug that in. And then we just need the output again and plug that up. Compile that, close that out, let's go back to our event graph. So once we click on the circle and the actual timeline stops, that's when we want to go ahead and make a new macro. And this is where we're actually going to compare the two scales and sizes of the two circles and see how close they are to each other's size. So let's go ahead and do another macro. We'll call it compare size of circles. They just need two executable pins, one for input called in, and another one for outputs, and we'll call that out. So we'll move the outputs one for right now. And what we need to do basically is get the world scale of each mesh, both the static circle and the dynamic circle, at the time of calling this macro. So let's get the dynamic circle mesh, drag out of it, get world scale. And then what we need to do is get the static circle reference, drag out of it, get static circle mesh, and then drag out of that, get world scale. So let's organize these a little bit. Okay, now we have the vectors for each one. And basically what we want to do is compare these together. And we want to basically kind of convert them to floats. But what we're going to do is break the vector. And the x, y, and z values are going to be the same for each individual one. So for example, the static circle mesh, the x, y, and z are all going to be either 1, 1.5, some sort of number. They're not going to be different at all. They're all uniformly scaled. And the same thing goes for our dynamic circle mesh. So all we really need to do is just grab either the x, y, and z of each one and just compare it. So we're only going to do the x. So let's drag it out from our dynamic circle mesh. And we'll do a greater than. So float is greater than float. And we'll compare it to the x of the static circle mesh. So we're basically asking, hey, is the dynamic circle mesh right now bigger or smaller than our static circle? And then we're going to do true or false based on that. So we'll grab a branch, connect it to our input. And then we need to copy and paste this logic we have highlighted here, excluding the comparison here. So let's copy and paste that. And what we need to do is basically, in order to get how close they are to each other, we have to subtract either the dynamic circle by the static circle or subtract the static circle by the dynamic circle. So depending on which one's larger. So let's first grab the x of our dynamic circle mesh and just do a minus. So float minus float. So we're going to subtract from the dynamic circle mesh the world scale x of the static circle, and then we're going to copy and paste that, and then switch it up. So then this one we're going to subtract from the static circle mesh x, we're going to subtract from that the dynamic circle mesh. And then just to make sure there's no negative numbers, we're going to get an absolute, and make sure that the number we get in the end is a positive number. And then from here, since we're subtracting the dynamic circle mesh by the static circle mesh, we're going to need to create two actual new float variables. Oops, that's a function. So let's create a variable, make it a float. We'll call this one dynamic minus sign static. Compile, leave its default value at 0. Make another variable. Again, it's a float. And this one's going to be static minus dynamic. Compile, leave its default value at 0. And so now, for the dynamic minus static, we're going to alt left click drag to get a setter. We're going to set the absolute value of that subtraction here. And this is going to be when this comparison is true. Do the same thing for static minus dynamic. This is going to be set when this is false. And then it's from here that we actually want to produce player feedback. There's going to be 5 levels of feedback, I believe. It's going to be perfect, excellent, good, okay, bad, and then miss. So that's actually 6 in total. So we're going to have to create another macro to set up the logic to provide player feedback. So let's do a new macro. We'll call it player feedback. For inputs, we're going to need an executable pin called in, but we're also going to need a float that we're going to call circle size comparison. And then for the outputs, we just need an executable pin that we'll call out. For right now, we'll move the output pins away just so we're dealing with the inputs. But back in our compare size, in this section, we're going to first throw in the player feedback. So just drag it out. We're going to have to drag it out twice. Connect it accordingly. So the circle size comparison of the dynamic minus static one, that's going to be our dynamic minus static float variable. And then for the circle size comparison for the static minus dynamic, it's going to be the static minus dynamic float variable. So let's compile that, and now we need to work on the actual logic of the player feedback macro. So what we need to do is just set up a bunch of comparisons. We're going to hard code in some values that we're going to compare everything to. So let's drag out the circle size comparison pin. We'll do less than or equal for float. First value is going to be 0.115, and if the size difference between the two circles is less than or equal to 0.115, that's when we're going to give the player a feedback of perfect. So let's drag out here, we'll do a branch, connect that up to the input. So if this is true, we're just going to go ahead and print a string. And in the string, we're just going to do in all caps the word perfect. If this is false, that's when we're going to go ahead and make the next comparison. So it's copy and paste the less than or equal to comparison. Make sure the circle size comparison float goes into the top section of that. But the second hard-coded value we're going to put in is 0.2. So we're going to pull out a branch here. Connect it to the false. But if this is true, we're going to go ahead and create a new print string. And in here, we're going to put the word in all caps, excellent. Now the next comparison, it's going to be the value of 0.3. So instead of 0.2, we're going to do 0.3. Create a new branch. The false of the previous branch is going to go into the executable input pin of this new branch. If this is true, we're going to do another print string. This one we're going to do is going to be all caps, the word good. The next comparison is going to be the value of 0.4. So let's hook up the circle comparison, hard code in the value for 0.4. Grab out a branch. Connect the false into this executable pin. And then from true, we'll do a print string. This string is going to say the letters OK in all caps. And then the last comparison, it's going to be 0.6. Just make sure the circle size comparison float is plugged in. Pull out a branch from the Boolean result of that comparison. Connect the false into the executable pin of that branch. For true, we're going to do a print string. It's going to be the word bad in all caps. But then the false, it's going to be another print string. This one's going to have the value of miss. So if the circle size comparison ends up being less than or equal to 0.115, we're going to say, hey, the player matched it perfectly and give them whatever amount of points. We're not really going to go over point values or anything like that. But then if the next time we compare, if it's less than or equal to 0.2, but also greater than 0.1 or 0.115, then we're going to do excellent. And then as we go, the numbers could be larger. And then eventually you're either going to hit a bad or a miss. Then all we have to do now is just grab our output pin, connect these all up. Compile that. And then back into our compare size of circles. We have that in place for our player feedback. All we have to do is hook up the outputs here. And then back into our main event graph. After we click on circles, we're going to go ahead and compare size of the circles. So let's grab that macro out that we've just been working on. Now we're going to get another delay. So you can hold down the D key and left click. This delay is going to be of 0.75 seconds. We're going to plug that up. Then we're going to need a static circle reference so that we can call the update static circle. And then we're going to need another delay. We're going to make this one 0.5. And then last but not least, we're going to need to do a set of the can input. We're going to set that back to true. So that's all the logic for the dynamic circle. So let's compile. All we really need to do at this point is go back into our static circle. At the very end section here, we're going to need to grab our dynamic circle reference called the set dynamic circle. Plug it up here. And then last but not least, we need to create a on-click event for our static circle mesh. So let's make sure that's highlighted. Let's right-click, filter for on-click, and then there's an add on-clicked. And whenever this is clicked, we're going to go ahead and call that click static circle function that we had made through that custom event in our dynamic circle. So in our dynamic circle reference, we can just pull out the click static circle. And that should be all that we need for everything to start working the way we need to. So let's try playing now. Okay, so we see that it's growing and that it's missing. And now we can basically click, stops, and then we get a comparison. So everything's working. And each time it's a new location, should be a new color, and the sizes are always different. So just to give a brief overview of what we did overall is in our static circle, we call update static circle, which is a custom event. And at the beginning of playing, we call from that our change circle's location. So in here, we're picking a random location within a range that we set deemable that suits it very well for where we are on screen. And we set both circles locations there. And then we generate a random color so that it's either going to be red, green, or blue as a primary color. And then we set a random circle scale anywhere that's between, either ×1 or ×3 or ×2. We get a random value within that range for the float, and then we set the scale of that static circle for that. And then we give the static circle intensity emissive property a random scale between 4 and 8, so it can kind of change brightness overall in a random way. And then we call this set dynamic circle event, which is this one right here, where we set the dynamic circle's color, we set the size of the dynamic circle, and then we start playing our timeline. And as the timeline is playing, we're either growing or shrinking, depending on the circle's smaller or larger to begin with. And then at any time, either we click on the static circle or we click on the dynamic circle, it will tell us, hey, let's stop the blueprint. Let's compare the size of the two circles. Depending on how close they are to each other, you'll get a specific feedback of either perfect, excellent, good, okay, bad, or miss. And then we take a couple seconds to delay things. We update the static circle again, so we're back at the start, and we basically have an internal loop. And that's why each time you click on it, it basically lets us start the game over. So that's going to be the end of this tutorial series. I hope you did learn a lot. I want to appreciate you guys watching. And again, my name is Devin Cherry. You have a good one, and thanks again for watching.